So the thing with scatter graphs is that we've got to be careful with the scale of the graph. So we can see that the scale of this graph is telling us that across here every square is worth 0.2, and going up here every square is worth 0.4. So it's got to be careful with scale. So that direction is 0.2 and that direction is 0.4. Okay, so the first question is asking us to plot the last two coordinates. So we've got 12 and 6, so 12 and 6. And then we've got 13 and 2, so 13 and 2. Okay, so that's that bit done. It then says describe the relationship between the average temperature and the number of units of gas used. Now, describing the relationship isn't just saying it's positive or negative correlation. We really ought to be thinking about working through what's actually happening. Now, although we've got a gap in the middle here, we've got some crosses there and some crosses down here, the trend seems to be generally as the temperature goes up, then the units of gas used goes down. So basically we're going to say here that as temperature increases, the number of units of gas decrease, which is basically negative correlation. But personally, I'd always be in the habit of describing what the graph shows you and then putting the correlation as well, because then you're covering yourself in both ways. The question then says estimates the average temperature when 12 units of gas are used. So basically we should always draw a line of best fit to help us use this. Now there isn't much data on here, so it's going to be very rough and ready. But literally what you're trying to do is you're trying to get the gap measured at right angle for the crosses above the line to be roughly the same as the gap, all the gaps added together below the line. So that's the general trend, the general idea. So it says do this when the 12 units of gas are used. So basically we come across to our line of best fit from 12 and we come down, and we've recognised the scale going across the x-axis. The temperature axis is going across in 0.2s, so we've got 6, 6.2, 6.4. So the answer for part C is 6.4.